Welcome everyone to our 63rd live stream in our space shooter DevVenture. So at the end of our last session, we had established, or rather not established, but we had corrected an error that occurred where the enemy projectiles weren't going very far. They would fire and almost immediately be deleted. And that on its own was an error because the projectiles were colliding with the ship, the enemy ship itself, which means they should never even have been emitted in the first place. They should have been destroyed at the moment they were instantiated. But for some reason, I think it was due to how responsive the engine is, or rather how unresponsive the engine is, the projectile actually got instantiated and was fired before it was taken out of the scene. Now, we fixed that by the end of our last session, and now what remains is that we have to test all of our various cases that we were going to test, right? So I need to establish those conditions in our testing seek behavior scene so that I can confirm or deny whether the code will work, right? And so let's go ahead and do that. Okay, so as you can see here, we have Perplexity open, and the last thing we were talking about is that the bolt is now correctly ignoring the danger sensor, but it's still colliding with the enemy ship body and being destroyed immediately after spawning because there is no filtering in plasma body entered. We've done this. We finished this, right? So we checked these things. We made the changes, and we need to let Perplexity know that it's working so that we can get on with the actual tests. So let's go ahead and run the scene and get the output so that I can take that output and paste it in Perplexity and let it know by virtue of the output itself that things are working, right? So I'm going to run the scene and I'm going to let it do its thing, right? So go over to waypoint number 2. And it's on its way. You can see it going. It performs a deflection, then a redirection, boom, and now off it goes towards a random waypoint. It looks like waypoint 5 according to the output, but now instead of doing that, I'm going to send it off to waypoint 1. And as you can see, it immediately interrupts the behavior and it's heading off towards waypoint 1. Okay. If you hear a lawnmower or a fan in the background, just ignore it. Bear with me. It is a very hot summer day here and they are mowing the lawn outside, so. Okay, so that's that. Everything's done. Let's get that output. Copy the output, paste it into Perplexity. So I think moving the bullet spawner, is it called the bullet spawner? I don't think it's called the bullet spawner anymore. Let me just check. If I go towards the, yeah, that's the lawnmower. My apologies, guys. Please just bear with me. Pirate enemy, gun pirate, show in file system. That's this. It's got a gun main, but it's called gun pirate in pirate enemy. Okay, so the gun NPC I think moving the gun pirate node outside the collision shape of the pirate ship was the fix. Among the code likely also had something to contribute, but the position adjustment had the biggest impact, I think. Here is the output from the latest run. As you can see, the projectiles are moving as they should and colliding with the target as expected. Shall we continue with the test phase now? Yes, this run is a clean baseline. Bolts behave correctly, danger sensor triggers once the flea exits via safe distance reached, and the attack pattern flows. Seek plus danger sensor override work in isolation. The ship flees from mining object 1 and returns to find waypoint without timeouts. Attack pattern runs end to end, arrival to shoot, multiple shots logged and applying damage to the target, and then flee. The current flee and attack pattern still times out. Behavior flee timeout, max duration reached, confirms the boxed in / bad flee scenario now shows up clearly, no longer polluted by projectile issues. That means the projectile versus safety radius problem is resolved, and what remains is tuning and triage behavior for flee. So the next test to run. Given that you now have an operational scene, the next useful step is test B, which is local flee timeout without a triage. The goal, confirm that a failed flee timeout cleanly returns control and log structure is as designed. The concrete actions: in the editor, create a single obstacle near the ship, use a mining target.tscn instance or a simple static body 3D. The position it so that danger sensor will trigger when the ship runs the attack pattern, but leave open space for fleeing. And then in behavior flee, set the maximum flee duration to be small and the safety radius to be relatively large, so it often can't fully escape in time. And then action 3 in the NPC behavior manager, set the override duration larger than maximum flee duration, and that would make the global triage so the global triage does not trigger yet. Then run it once, let it complete the attack and flee, then paste the log. From that we can then verify the timeout path is firing consistently. We can confirm that no global override or triage message appears, and that and we can then move on to the so-called boxed in tests, where triage levels 1, 2, and 3 should activate. If you prefer, we can instead just jump straight into the fully boxed in surrender to Centroid case, but the above B test is the smallest next rung in the staircase, or the ladder is a bit a metaphor. Anyway, So let's do these. I'm going to move this off to one side, and I'm going to start implementing these changes and do the test. Okay? So if you want to know the steps for yourself before I move it aside, you can pause it here, but off it goes. Okay, so we are back in Godot engine. In testing seek behavior, we need to go into the editor, create a single obstacle near the ship. Use a mining target.tscn since a simple static body 3D, a mining target instance or a simple static body 3D, and position it so the danger sensor will trigger when the ship runs the attack pattern, but leave open space for fleeing. Okay, excuse me. So let's focus on the player over here. We'll zoom in, right? So the player is facing waypoint 2 at the moment, right? Now waypoint 1 is over there. So what I need to do is set another mining object. So I'll duplicate it, and that's mining object 2. And for mining object 2, as you can see, it's already tagged in the group mining object. In the inspector, for transform, we can see that the position is minus 46. But on the X and Y, we can change these to be 0 and 0 for both. We'll set this to be 0, 0 as well, right? Now, mining object 2, we can change, instead of being on the Z axis as negative 46, we can just cut that and paste that into the X axis. And instead of making it negative, we'll make it positive 46. And we'll turn this to 0. And there it is, right? It's directly in the way of the target, right? Now, what I want to do is, because it's going to curve like this towards the waypoint, we want to move this outwards towards the Z side by an amount. So I'll set it to be 15, negative 15. Something like this, right? We expect it to do kind of like an arc towards the target over here. So I'm going to save that, and I'm going to run the scene, and we'll see what happens. Okay, so here's waypoint 1. If I do this, we should see. Okay, it seems like 15 was just a little bit too far out. What I'll do instead is make it like negative 3. Okay, something really small. And press the attack pattern once again. That is more like it. It looks like it's going directly for the thing. It should trigger, do an avoid. Go for waypoint 1. Fire. 1, 2, 3, 4, and 5, and then off it goes. Okay, so that's the first step. Now we need to do 2 more steps. Well, 3 more steps actually. But the third step is just to run the scene and paste the log, right? So 2 more steps to do edits, and then the 4th step is to actually test things. So in behavior flee, which is a script, behavior flee.gd at the top, we must change maximum flee duration to be a small value. We'll make it like 2 seconds, and we'll change the safety radius, which is here, to be large, which it is 80, right? And then in the NPC behavior manager, which is over there, we must set the max override duration, which is here, to be larger than the maximum flee duration. which is 10 to 15, which we've done that. Okay, now we can run it once and paste the log into Perplexity. So off it goes. We don't do anything else except the attack pattern, right? So it does the attack pattern, goes towards waypoint 1, does a dodge, comes back towards waypoint 1, fires its shots, and then does its flee. Okay, so it seems like it timed out. Perfect. So I'm going to copy that, paste it into Perplexity, and then we can move on to the next testing phase, right? So here we go. Here is the, or rather I say, I've done the changes you recommended. Here is the output from the latest run. That's it. I'm not going to mention any other problems yet. Let it analyze this, then we'll talk about problems. The log shows a good local timeout flee test. The flee starts, it hits its 2-second limit, reports a flee timeout, and the manager restores the pattern and continues through arrival, shoot, and then to another failing flee, right? And what does this run confirm? It confirms that the override path is clean, that danger sensor interrupts arrival, starts the flee, and on timeout you get override behavior flee completed with status failed, then a clean restore to attack at index 0. The attack pattern is resilient. After the flee fails, the ship does arrival to target again. It shoots with bolts hitting the target and applying damage. The pattern flee at the end of attack also times out and reports a flee timeout without breaking anything. So you are now squarely in the flee tuning triage space. The failure is no longer a bug in projectiles or sensors. It is designed, or rather it is the designed flee could not escape in time or distance branch. The next step is to introduce the triage or boxed in case. Right now, only the pattern local flee timeout is firing. The global override limit or triage logic has not kicked in yet. And to move forward with the planned test staircase, we need to do test C, right? And so these are the steps we need to follow. Arrange several obstacles around the ship so that flee struggles to reach a safety radius. Then set behavior flee, safety radius moderately high, maximum flee duration a bit smaller. The NPC behavior manager, and then, or rather, yeah, okay, so we've done those two changes, haven't we? 80 and 3 in behavior flee, 80 and 2 or 3 is fine. Okay, then in Perplexity NPC behavior manager, Perplexity was saying the override duration has to be small, like 4 or 5, so that that if flee keeps getting called from danger sensor or pattern flee, that the manager's global timer trips. Okay, so we need to change that to 4 or 5, maximum override duration. Where's this thing here? 4 or 5. So we'll make that 5. And we'll save that. Okay, and now we need to run and test, then paste the logs in place, right? But the first thing we obviously have to do is this. We need to set up more obstacles around the ship so that flee struggles to reach the safety radius. So we're going to do a boxed in, like a buckyball, right? Now that's going to be a bit tricky, but we'll manage, hopefully. what we'll do is we'll go into the 3D scene and we will create quite a few mining objects. Okay, this will take a while, but it's worth doing so that the test can be confirmed. We can always either delete those mining objects or hide them or move them so that it's no longer boxed in, but then the mining objects are still all over the scene, right? It's useful to have them and not need them than to need them and not have them, right? And in this case, we are currently in need of them but don't have them. So let's go ahead and set them up so that we have them, test with them, then we don't need them anymore, and we are in the ideal situation, right? Although if you take that to an extreme, that's hoarding. So just, you know, moderation, I suppose. Duplication, and then relocation. So along the curve at 45 degrees between the two of these. So the radius is 46, right? The distance between these 2 points is what exactly? The hypotenuse of this here is 46 squared plus 46 squared. Okay, and then we take that value and halve it. So let's do that. 46 squared times 2 equals this, and then we square root it, is 65. Okay, so half of 65 is 32. Right? So now we have a value 32 along this axis. Now how do we get 32 from two equal components? Do you see the problem? Right? So let me do the calculation. Right? Switch on my pen. We did the calculation here. But I'm going to do another one here. So I'm going to change the color to white again. And we'll draw yet another circle over here. Right? Then we need to draw 2 right angles. Like that. Okay, then that's the right angle. And now we change the pen color to be green again. Set the thickness to be 3 again. We draw the line like so towards. I thought I set it to green. Like that. Okay. And then I want to know what is that distance and that distance. Right? So we need to do a yellowish color. That's fine. Right? So now I want to know what is that distance and that distance. Okay, so this is x, and blue is Z. It's just a little too dark. Maybe we'll make it a lighter blue, a brighter blue, something like that. Okay, now I want to know what are the components of that length, and we calculated the length was 32.5. so this here is 32.5, so we'll change that to be 32.5. that is way too thick. Set that to be 2, right? So here we go, 32.5. okay, and we need to know what X and Z are, so here we go. The square root of 32.5 squared, so Pythagorean theorem, right? We'll change this to be cyan because I like cyan, right? So the square root of 32.5 is equal to the square root of x squared plus z squared. Okay, but x is the same as z in this case, right? Therefore, root 32.5 is equal to the square root of 2x squared, which is equal to root 2 times x. Okay, therefore the square root of 32.5 divided by the square root of 2 is equal to x. So what is x? We can find out, right? The square root of that is 5.7. It's equal to 5.7 divided by the square root of 2, which is just, okay, so 5.7 divided by the square root of 2 is 4 on the dot. That doesn't seem right. Oh, my mistake. It's root 32.5 all squared. So this needs to be added in. So let me take a red pen, scroll right up to the top here, and add in a squared symbol to each of those. So to the power of 2 to the power of 2 equals 5.7 squared this is wrong, actually. It's just fully wrong. This is wrong. Okay, and turn off the eraser, set this to 2, right? Now 32.5 squared is this, right? 1056.25, the square root of that is 32.5. So the answer is actually not the square root of 32.5. The answer is just 32.5. So let's turn this up to 10 and then just go ahead and erase the whole square root thing on this side. Just in general, you should know that, you know, x squared, or rather a squared plus b squared equals c squared. Therefore, the square root of c squared, which is c equals the square root of a squared plus b squared. So that's what we're doing. And we are just undoing a fundamental mistake in the calculation that we've done, right? So just bear with me as I figure out the way forward. To turn off eraser. No, it needs to be cyan. There we go. Right, so 32.5 over root 2 equals x. Therefore, x equals what is x equals? X is equal to 32.5 divided by the square root of 2 equals 22.98, which is roughly 3. 22.98, which is roughly equal to 23, right? So each of them, x and y, or rather x and z, can go to 23. So over here, for waypoint mining object 3, we've calculated it now. So we can do a spherical arrangement easily now because we've got the radius, right? In the transform, we can now say for x and z the same values, right? Waypoint 2 can go back to 0, and waypoint 3 can go back to 0. But first it goes to 23 and negative 23. Is it really 23? Is it not 32.5? I think it is 32.5. So I did all of that calculations for nothing. Ugh, that's annoying. And I also got it wrong. That's kind of disappointing. Whatever. Right? So it's either on the axes, it's 46. The radius is 46. But the 45-degree components are 32.5 each. Okay, so now I can make another one, which is just mining object 4. And in the transform, I can add to this 32.5 like that, which takes it up, right? And then, of course, because it's in a 3-dimensional space, it's a 3-dimensional hypotenuse, you have to do a cube root instead. So this is not correct. But rather than waste all kinds of time doing the calculations, we'll just move it by I, right? So And if you notice, this one is also just a little bit too far out. It should be moved inwards, but it's okay. It's fine. We'll just make it a spiky sphere. A spiky sphere. Or we could make it an actual box. Why don't we just do that? 46. 46 minus 46. This one, 46, 46, and minus 46. Now we've got the vertices of a cube, right? And then we can duplicate this one, right? And then go into the transform. And on the x-axis, set this to be 0. And then duplicate it again. And in the transform, we can change the z value to be positive 46. No, negative 46. And change this to be negative 46 there. So now we've got downwards. And then we can duplicate this one again. And set the x value to be positive 46. Then duplicate this and set its x value to be negative 46. Right? And then was it 7, 4, 3, 2, 1. Okay, so we'll duplicate 1. And set this to be negative 46 on the x-axis. Okay. Then we take that one and duplicate it and set the y value to be 46 on the positive values. And now I've got a nice big fat wall of vertices. Okay. However, what I'm thinking about now is that they are just a little bit too far out. And so what I'm going to do is I'm going to change this to be 23. Like really close to the ship. Okay. So just bear with me as I change things down to be really tiny. Okay. That's looking better. Okay, so over here we can duplicate this one, and in the transform we can set this to be 0 on the z-axis. Okay, then duplicate it and then put it 0 on the y-axis, and then duplicate it and then put it minus 23 on the y-axis. then set that to 23. Okay, and then set that to be 0. Oh yeah, duplicate, then set it to 0. And then set it to be positive 23. And then this one can duplicate and shift it right to the very bottom. In the transform, we can set it down to 23, then duplicate that and set it to minus 23. Okay, and now all we need to do is make one in the top and one at the bottom, right? So I select this one, duplicate it, okay, and then here I can set this to be 0 on the x-axis, and then duplicate that, and then on the y-axis I set this to be negative 23. And we've successfully boxed in our pirate enemy. Okay, hopefully now I can run the scene, but before I do that I want to just do this: show in C file system, open in external file manager, and then copy this and paste it into Perplexity. I've done the changes to the scene as you recommended. Here is the new testing seek behavior.tscn file. And here is the output from the latest run. Okay, now all that remains is to actually run the test. Right, so run the test, and we should see logs like this. So let's do that. Hopefully this is enough to box in the player. Go towards a random waypoint. Didn't work. As you can see, the enemy ship did not get boxed in. Instead, it flew straight through the mining object. And carried on towards the destination waypoint after the flea was done. Perhaps we need to rethink the flea angle to something more like a rebound rather than a graze. When hitting an avoidance obstacle. What do you think? The current setup proves that flea is triggering and timing out, but the ship is skimming past the obstacle instead of actually getting trapped, because the flea direction is mostly grazing along the cluster rather than pushing back into it or strongly away from it. From the log, danger at 2300 and flea direction, the values that you see on the screen, that is a vector that is slightly away in X and strongly forward in Z. So the ship is doing a shallow sideways and forward dodge and then continuing its original journey. The so-called mining shell is not dense enough in the direction it's fleeing to actually cage it. So 2 levers. Geometry, the obstacle layout must actually block the chosen flea direction. And vector math, the flea direction should give a strong push away from the danger and or the center, not a small perturbation of the current path. Concrete change, make flea direction more of a rebound. Okay, so here's what I'm thinking. Instead of boxing it in completely, let's do the walled it off. Like, let's just wall it off, right? So we'll make a big, like, barricade of obstacles. Kind of like a concave barricade of obstacles like that. Going up and around like this. But it can easily go around like that. If it decides to have a strong enough angle away from them all, right? The problem, of course, with that is it's not boxed in, right? If we really do want to box it in, we're going to have to make more of these mining objects in the grid around the pirate, or we make the distance even smaller. Which do you think makes more sense? Shall we make it smaller? Why not? Let's choose this one and move it in so that it almost touches. Almost touches the collision shape of the pirate vessel. Kind of like that. Now we check the transform. That's about negative 12.6. So we can make it 15. Something like this. Okay. And then for the rest of them, we can change all of these to be 15. The they're all moving in on the z-axis by that much. And then these guys will do the same thing on the x-axis. Right, so the transform will bring it in on the z to be negative 15, like that. Okay, and now these guys, we'll move them in on the y-axis to be 15. And then these guys will bring them in on the y-axis to negative 15. And then those ones will repeat the process until everything looks okay. Okay? So x, bring it in to 15. And then here we change that to be 15. Okay, so now we can do this to figure out exactly which waypoints they are. It's just waypoints 17 and 18. Like that. And that looks more or less like a cube again. Okay, so let's go ahead and test that. We'll run the scene again. This time, set it off towards a random waypoint. I changed the distances to be 15 instead of 23, and then ran the scene again. Here is the output from the latest run. It still escapes the box. Does this mean our concerns about dodging avoidance objects and needing a triage system were overkill and unlikely? What this run shows is that your current box is still porous for the specific flea vector you are generating, not that the triage idea was unnecessary. Flea does get activated by a nearby danger. The flea direction is that, which is almost entirely in negative x, with only a small backward z component. Your mining cluster is centered near the ship, but the particular direction apparently finds a gap and exits the shell within 2 seconds. Then seek completes to find the waypoint. So the system is not over defensive. It's simply that the flee angle is not guaranteed to drive into a trap. The obstacle field is not fully enclosing in that exact direction. In a real game, this is fine and desirable. Most of the time, the ship should successfully dodge and escape. The triage system is about pathological cases, dense clusters, corners, bugs in advance, where multiple attempts still fail. So the triage idea is about resilience, not everyday behavior. There will be maps or generated asteroid fields where navigation fails to find an escape. Flee keeps timing out in the same region, and in those cases you don't want infinite oscillation between flee and the main pattern and ships stuck forever burning fuel in place. A simple triage ladder, reduced safety radius, emergency radius, and surrender to centroid gives you a guaranteed convergence path from try very safe to just get out of this cluster somehow to, if that fails, park safely. That's not overkill, it's a circuit breaker for edge cases. How do you interpret the still escapes the box? This result mainly tells you that your test rig is not yet a true cage, with spacing 15 units apart and that flee direction, there is still a corridor. Your flee parameters are in a reasonable game zone. 2 seconds of fleeing at your current speed is enough to leave the cluster. So, if the design goal is to prove triage by making flee hopeless, you need a tighter, more spherical shell with no directional gaps, or a flee vector computation that biases into the densest part of the cluster for testing only. If the design goal is decide if triage is worthwhile, your current data says normal avoidance is working well enough that simple boxes at 15 to 23 units apart are escapable. Triage is still is still useful as a safety net, but you will need a more extreme test scenario to exercise it meaningfully. Suggested next move, small, low activation step, don't change the code yet. In the editor, build a visibly unfair cage. Put mining objects in a tighter sphere all around the ship, leaving no obvious corridor in the printed flee direction. And keep the maximum flee duration at 2, the safety radius at example 80. Then run it once, or rather run that once. And if it still escapes, then your flee speed versus duration versus obstacle layout may escape very likely. Make escape very likely, and triage will seldom fire in practice. If it starts to jitter and repeatedly re-trigger danger sensor but never reaches safety, then you have exactly the pathological case triage is designed to clean up. From there, you can decide pragmatically. If you never see that pathological behavior in a deliberately hostile test scene, you can keep triage very simple or even dormant. If you do see it, the triage ladder is justified and will probably pay for itself the first time a procedural asteroid field generates a nasty corner. Okay, so we've got about a minute left in the live stream, so I'm going to call it here. Just because setting it up to be even tighter is going to take too much time, and I don't want to waste that time doing something so tedious. I think tedious is the right word. So I'm going to call it here. Okay, so I'm going to make a shout out to Cubes. He's our junior DevVenturer at coffee.com/mtkdev. That's the link over here. It's also in the description of this video and all the previous ones, right? So head over to coffee.com/mtkdev. Check out the membership tiers. We've got the intern DevVenturer, the junior DevVenturer, and the senior DevVenturer. And each of those give you perks, and the perks are listed on the Coffee page. If you don't want to be a member with a monthly subscription, you can do a once-off donation as well. Anything is appreciated. And on top of that, I have a Discord community, and you are welcome to join it. Right? The link is in the description of this video. Go ahead and join the Discord community. That's where I post the links and announcements to all the content I create on all the various platforms, right? And then on top of that, you can support the channel by liking this video and subscribing and joining me in all my future live streams and videos that I post. And any support in any of its forms is very much appreciated. So having said all of that, thank you so much for your time and for your attention, and I'll see you in the next live stream.